start running through my advented code solutions and upload them to YouTube. I don't know if I'll stick to this, but let's see. So I'll just run through my code for the demo code. So I'll put the demo code in here as it is. There's no line breaks before or after it. First thing I do is just load the data in, and put a blank line before and after it, just so I can detect the start and end of each of the maps, which I then do just by simply looking for the blank line, so we know that the blank line at 1, 9, 17. So we can now loop through each of the maps. Yeah, let's just create a simple loop from 1 to the n minus 1 of these, so at least we can get the ranges. And then we just simply load the map in as a character. So for the first map, I've also pre-allocated my results array here. We'll come back to that later. So for the first map, we can load the map in as m. Again, so just loaded that in, but I've also converted it to a char array just so we can more easily index into the array, because it's a bit more tricky using the extract between and comparisons and flipping a string array. So char arrays are much preferred today. First thing I do is I call my process map function, which processes this map and looks if there are any reflections with the reflection point in the vertical plane. I don't consider the horizontal plane, I just consider the vertical plane. So when we call the process map function, we go into here. Obviously, what I need to do is I need to consider whether there's whether the mirror location is after each of the. It could be after the first one. It could be after the penultimate one. So yeah, so it could be after the first one, or it could be after the penultimate one. Obviously, it can't be before the first one. It can't be after the last one because there'll be no reflection then. So I just basically build an array of where the mirror could be. Something I need to then consider. I then need to build. I need to loop. I loop each of these. So I consider the situation where the mirror is here. So loop each of these, and I then consider how wide it'll be. So if I'm looking after 1, then there's only 1 before it, so we just have to have 1 after it. If I'm considering, say, this one after 7, there's 2 after it, so there's going to have to only be 2 before it. So just find the minimum of before and after. That seems to work quite well. So for this one, the width is just 1, because we have column 1 and column 2 at the only 2 we want to compare. So left hand side, again, you just extract from the map that first column. Right hand side, just extract the second column. Obviously, this is a bit of maths on the width of the column and the width of the map. There's a few things, and then all we need to do is check if these two are the same. If these two are the same, oh sorry, I also flip the right hand side, left and right. So the reflection is undone. So now, if they're both exactly the same, they'll match, and I return. And the thing that I return is the position of the mirror. The position of the mirror when it finds the match. If it gets to them all and it doesn't find a match, it just sets the position of the mirror to nan and returns out the function. So then we set that result to be the second column of the results array. And if it's a nan, what it means is it hasn't found a mirror in this vertical plane with vertical lines. So now we need to check the horizontal lines. So rather than right now going to check the horizontal lines, all I do is transpose the matrix. So if the result of this was a nan, then just run process map again, but with the rotated matrix. So you just transpose the matrix, run it again, and then the way my results array works is that we, at the end of it, sorry, breakpoint somewhere. At the end of it, what I end up with is R. So R says this was not rotated and it was after 5. This was rotated and it was after 4. So all I do then is if it was rotated, I just times the number by 100, and then I just take the sum of that second column. Again, so you get 4 or 5 from the demo. So now if we run this on the full code, this is the full code. Oh, breakpoint. So again, we've got all these. So it's rotated a load of them. It hasn't rotated a load of them. This is where it's found the point of reflection. And then, so yeah, just do the sum, and then there's my answer. When we move on to the second part, again, it's basically exactly the same. The only thing that changed is this line. So we do exactly the same, but when we get to this point, we're not looking for a left-hand side, right-hand side match. We're looking for where the number of non-matches is equal to 1. So I just could do the left-hand side, right-hand side, and then compare them to false. So now this will give me a logical matrix of non-matches. Oh, yeah, sorry, obviously stupid. Just want to know where they don't match. So yeah, so this just shows where they don't match. Then I sum all of the non-matches, and if they equal 1, then that's it. That's our smudge. So we found it. So we can return. So now if I run this, I just get my result for part 2.